Welcome to the deep dive. Today we're heading back, way back to the early Cretaceous in what's now north-central China. We're going to be digging into Auroraceratops. It's a small but actually pretty significant dinosaur. We've gathered the research, discovery, anatomy, its world, and our mission really is to understand what this dinosaur, the Dawn horned face, tells us about the very start of the horned dinosaurs.
Exactly. Auroraceratops, I mean, the name itself, dawn horned face, it really sets the stage. Aurora for dawn, ceratops for horned face. It's partly for its early place in the lineage, but it's also a nice tribute to Dawn Dodson, the wife of paleontologist Peter Dodson. He was involved in describing it.
Okay, let's unpack that.
Yeah.
Early Cretaceous, Aptian Age, north-central China. Got it. But why Auroraceratops? What makes it so key to the whole dinosaur story?
Well, its importance really comes down to its position. It's what we call a basal neoceratopsian. Think of the horned dinosaurs like Triceratops and its relatives as a big family tree. Auroraceratops sits near the bottom of one of the main branches, the Neoceratopsia branch. So it's an earlier, more primitive relative of those later, much bigger, more famous ones. Studying it gives us this critical glimpse into how those features we know, the frills, the horns, how they actually started to develop.
Right, like seeing the early sketches before the final painting. A great way to put it. So how did we even find this thing, this dawn-horned face? It wasn't just found yesterday, was it?
Oh, no, not at all. The discovery story goes back quite a way, actually. It's tied up with digs in the Gansu province. It arguably started way back with the Sino-Swedish expedition in the 1930s. They found some bits, including something called Microceratops sulcidans, though whether that's really an early ceratopsian is a bit debated now.
Okay.
Then you had sporadic finds, bones spotted in the 60s, again in the 80s. Little hints.
Just little clues scattered around.
Exactly. Then things picked up. Late 80s, the China-Canada Dinosaur Project did some scouting, but the real turning point was probably the Sino-Japanese Silk Road Dinosaur Expedition in the early 90s. They found Archaeoceratops, that's another key early horned dinosaur, and that really put the Mazhongshan region on the map as a fossil hotspot.
So one discovery kind of snowballed into the next, building momentum.
Precisely. Then came the Sino-American Mazhongshan Dinosaur Project, late 90s, and while they were working, in 99, they flagged the Yijingzi Basin as looking really promising. And sure enough, the first dino fossils popped up there in 2000. A Chinese paleontologist, Yu Hailu, was part of that team.
Yu Hailu. That name sounds important for Auroraceratops.
Absolutely central, yeah. In 2004, he teamed up with Li Daking, and their work led to digging in both the Yijingzi and, crucially, the Gongpukwan basins. And it was in Gongpukwan that they hit the jackpot, the holotype.
A holotype, the defining specimen.
That's the one. Specimen CAGS IG 2004 VD001. When Yu and his team studied it, they saw it was different, distinct from Archaeoceratops. Different enough to name not just a new species, but a whole new genus. Auroraceratops, that was in 2005. And the species name rugosus, that comes from the skull and jaws having this kind of rough, bumpy texture.
Rugosus rough. Okay, I like that. Sounds tough.
Yeah.
But finding the holotype in Gongpukwan wasn't the end of the story, right? You mentioned another basin.
No, not at all. The Yijingzi Basin turned out to be, well, incredible. A real treasure trove. Between 2006 and 2007, a big collaborative effort. Field Museum, American Museum of Natural History, others, they found a ton of Auroraceratops. We're talking about a concentration, almost like a graveyard. By the end of the 2010 season, they'd found remains of over 80 individuals.
80. That is an unbelievable amount of data. Were they just fragments or?
Remarkably well preserved, actually. Many were found fully articulated. Yeah. Bones still connected, just as they were in life. Mostly found individually, but sometimes a few together. Maybe hints of social groups. We don't know for sure. There was one specimen, GGM FV00500, they initially thought might be something new. But a closer look in 2019 confirmed, nope, it's also Auroraceratops rugosus.
Okay, so this wealth of fossils gives us a really detailed picture. Let's get into that picture. What did Auroraceratops actually look like? What are its defining features?
Well, first thing you'd notice is the skull. Compared to other early Neoceratopsians, its snout was shorter and wider. The whole skull was sort of flat and broad, about 20 centimeters long, so not huge.
Sure.
It also had these interesting teeth right at the very front of the upper jaw on the premaxillae, at least 2 pairs. And they were striated, kind of ridged, almost fang-like, but likely for plants.
Striated teeth at the front.
Uh-huh.
Interesting for an herbivore.
Yeah, probably helped grip tough vegetation. But maybe the most distinctive thing was these paired, roughened patches on the skull, these rugose areas. One pair in front of the eyes, another on the cheekbone, the jugal. And there were matching rough spots on the lower jaw, too.
Rugose. So bumpy, like horns starting to form.
Not quite bony horns. The thinking is these areas were covered in keratin, like our fingernails, or rhino horn material. So, yeah, bumpy, tough pads.
What would those be for? Defense, maybe?
Probably not great for defense against big predators. The main idea is they were for interacting with each other. Maybe for pushing or headbutting contests.
No.
Perhaps related to mating rights or sorting out social hierarchies. Intraspecific stuff.
Little headbutting contests.
Yeah.
Okay, I can picture that. What about the rest of it? Was it a four-legged tank, like Triceratops?
Actually, no. That's one of the really interesting things. Studies of the skeleton behind the skull, the postcranial stuff, published in 2019, they strongly indicate Auroraceratops was primarily bipedal, walked on two legs.
Really? 2 legs?
Yep.
It wasn't very big. Stood about 44 centimeters, maybe 17 inches tall at the hips. Total length around 1.25 meters, so just over 4 feet. And it weighed maybe 15.5 kilos, around 34 pounds.
Huh. Small, agile, two-legged. That completely changes the image.
It does.
Mhm.
It shows that the four-legged stance of the later giants wasn't the starting point. Auroraceratops gives us this snapshot of an earlier phase when these guys were maybe more nimble, filling a different sort of ecological role.
Fascinating. Bipedal, relatively light. Okay, so what kind of world did it live in? Let's talk paleoecology.
Right, so Auroraceratops is a key part of what paleontologists call the Mazhongshan dinosaur fauna, or MDF. We find these fossils in those 2 basins we mentioned, Gongpokwan and Ujingzi, and the time frame is mid-action to early Albian. That's all within the early Cretaceous period. Geologically, the fossils come from the Shinmintu group, specifically layers called the Xiagu and Zonggu formations. Auroraceratops itself, in the Ujingzi basin, is found in the upper red sandstone layers of that Shinminpu group. Red sandstone?
Mm-hmm.
Makes you think dry, maybe rocky. What else do we know about that environment back then?
It's interesting. Scientists looked at carbon isotopes in those Ujingzi sediments, and they seem to correlate with something called the Pakier event. That was a big ocean anoxic event, basically, low oxygen levels in the sea. It happened late Aptian to early Albian, so a time of pretty significant environmental shifts, which would have affected plants, other animals.
Okay.
Radiometric dating helps pin Auroraceratops down to the lower Albian in Ujingzi. Over in the Gongpokwan Basin, it's also found in red beds. But some other rock layers there, the gray beds, are actually younger. In fact, Auroraceratops is so consistently found in certain layers.
Ah, you mentioned this before.
Yeah, it's used biostratigraphically. Basically, if you find Auroraceratops, it's like a time marker for those rocks. It suggests all the layers with Auroraceratops in the Gongpokwan Basin belong to the Zonggu Formation, and the red beds are the oldest part of that.
So it's not just a cool dinosaur, it's a geological clue stick, helping map out the past. Who else was living there? It wasn't alone, surely.
Oh, definitely not. The Mazhongshan dinosaur fauna was pretty diverse for its time. Alongside Auroraceratops, you had several theropods, the meat-eaters. There was Zhongguanlong, an early type of tyrannosauroid.
A relative of T-Rex.
The distant early one, yeah. Then Beijinlong, an ornithone mammosaur, think ostrich mimic. And Suzusaurus, a therizinosaur, those strange ones with the long claws. Plus another unnamed ornithomimosaur and a puzzling neurosinosaur called Nenshungosaurus bolini.
Quite the lineup of theropods. Any big plant eaters?
Yep. We find sauropods, the longnecks, Gobitatine and Keowanlong. They belong to a group called Symphospondylans. And there are also early hedrosauroids, the ancestors of the duck-billed dinosaurs. Names like Equijubis, Gongpokwansaurus, Zhuolong, and Gintosaurus.
Wow.
And importantly, Auroraceratops shared its specific habitat, those red beds at the base of the Zonggu Formation, with the other early Neoceratopsian, Archaeoceratops oshimi, plus Beijinlong, Susasaurus, and some of those other theropods.
So it was living right alongside another early horned dinosaur type, a busy place?
Absolutely. A really dynamic early Cretaceous ecosystem. And it's incredible how much we can piece together from these fossils.
It really is. So summing up, Auroraceratops, the dawn horned-face, it gives us this crucial look at the early evolution of ceratopsians. Bipedal, those unique rough patches on the skull.
And its place in that diverse Mazhongshan fauna.
Yeah.
The sheer number of fossils is amazing. It's like opening a window onto that specific time.
An incredibly valuable window. Okay, so we've taken this deep dive into Auroraceratops, traced its discovery, pictured its anatomy, placed it in its world. But it leaves you thinking, given its small size, those big predators around, what other tricks might it have had up its sleeve for survival? Things maybe the bones don't obviously show. And you also wonder, how did these early Relatively modest ceratopsians like Auroraceratops set the stage. How do they pave the way for the giants like Triceratops that came so much later? It really highlights that long, fascinating evolutionary journey, doesn't it?